Right, but today we are performing site to site. This is our task. So this is my internal router, and this is my another branch internal router. This is branch 1, and this is branch 2. I want they can communicate securely. So I will create a VPN between R2 and R4. So let's configure it. First I will assign the IP addresses. So this is my internal router, internal PC. So I will give a default route, because usually in the PCs we used to give the default routes, right? So I will assign the IP to the edge router. This is my 1.2 shut and interface at 0/1. This is my edge. So I will assign the public IP notion. So basically on the edge router we used to assign a default gateway. So I will assign a default gateway 101.1. This is my ISP router. Host name ISP. We are not going to configure any default routing, static routing over the ISP. Notion. And I will give a default route. Now we will check the reachability. The name, this is my ISP. PC1. PC2. Branch 1. Branch 2. Branch 2. ISP. First we will check our reachability, whether my PC1 can ping my ISP edge router or not. It can ping, right? Now I will check whether my branch 1 can ping the branch 2 or not. It can ping. The third thing, whether my PC2 can ping my edge router or not. Finish. Now we will do the configuration. See the configuration. Config crypto IPCAM policy. We can create 10,000 policies. Lower the number, higher the priority. It will always check the policy 1, 2, 3, 4, 5, 6, 7, 8. So I will give him policy 1. In this policy, I can define only these things. So the first one is authentication. I will say use authentication pre-share. So I will already share the key. So when someone is coming from outside, I will check the key with the IP address. Encryption. See, we have these encryption. We already discussed about it, right? Dash, P dash and AES. So I will use AES. Hashing. We already discussed MD5 sharp. So I will use MD5. Group 1 to 5. I will use 5. The use of the group to generate the symmetric keys over a unsecure channel. Lifetime I will give 1800. To show history. Authentication, encryption, hashing, group, lifetime. That's it. Anything left? No. So in this authentication, I already defined. I will use pre-share, right? So I will define the key. Crypto ISACAN key. I have two options. I can put unencrypted or encrypted. So in this scenario, I will put unencrypted. So 0. Cisco. And the address. On R2, I am saying if someone is coming with this IP, plus it should have a key. Cisco. I am already defining that if someone is coming with this IP and this key, then only make the VPN. I need to define here that if someone is coming with this key Cisco and the address is, please check the address and the key. If someone is coming to you and he is asking for a VPN, that let's make a VPN. Please check IP should be 102.1.1 and the key should be Cisco. Now I will say crypto IPsec transform set, a name tsec. Transform set is phase 2. Phase 2, yes. ESP, AES, ESP, sharp. HMAC is automatically come. That is one of the features. Hashed message authentication code. So we will discuss it in chapter 18. Okay, we will use MD5. It will come automatically. Hashed. Yes, message authentication code. We have here different options. Mode. I can use mode. That I want to encrypt my packet from layer 3 to layer 7 or from layer 4 to layer 7. So I'm not going to configure it here anything. This means I am saying by default encrypt my packet from layer 3 to layer 7. So if you are not mentioning here anything, this means I am saying encrypt my packet from layer 3 to layer 7. To show history. I will copy this same configuration on the branch 2 and I will mention here the key should be for this. Right? And I will say here the phase 2 should be now I told you already about the access list, right? That you need to encrypt when the source is this and destination is if my this traffic is going somewhere towards Google server, don't encrypt it because Google server does not have the keys to decrypt. So he will drop the packet. IP access list extended 100. Permit IP host. Source is this. You need to encrypt when the source is this and destination is Now I need to apply this access list and transform set to the interface. I cannot apply directly, so I will use a method that is called crypto map. The name of the map is my map. I will give any number 10, 20, 13, 15, whatever you want. And I will say map all the configuration from IPsec to see. This new crypto map will be remain disabled until a peer and a valid access list have been configured. So I will first configure the peer set peer. This crypto map is for this IP. So if someone is coming with this IP, use this crypto map. The second one is valid access list. Match address 100. Now encryption is optional. Encryption and hashing is optional, but I already defined it, right? Encryption and hashing. So I will say set transform set tset, and I will apply it. Interface f0/1 crypto map. It will generate a notification. Outbound, always outbound. That when my traffic is leaving this interface, I will create same here. Crypto, not crypto. I will define IP access list extend 100 permit IP host. Here the IP source IP will be 2.1 and destination is because here source is 1.1 because why? Because this is my source, right? My traffic will be originated from here, and in R4 my traffic will be originated from. So this is my source and this is my crypto map. My map, any name, any number, and map all the configuration from IPsec to ISACAM. Set transform set tset set here. Use this crypto map for the branch 1 IP address and match address 100. Crypto map. My configuration is finished. What if in the exam your VPN is not coming up? What you will do? Okay, let's take an example. Suppose I will change the policies. I will say encryption is DES. It should be same, right? It should be same on the both ends. If encryption is not same, my VPN will not come up. So to yes. So to troubleshoot is always run debug crypto ISACAM. Debug crypto ISACAM. Let me start the Wireshark also. Now let's initiate the traffic. In 2 dot sources 1 dot see not working right because my encryption algorithm is not same. I told you that in the first packet, see I told you that it works on undebug all. It works on UDP 500, right? 500. Source port is, destination is, encryption algorithm does not match. So after viewing this command, you can easily figure it out. Okay, my encryption algorithm is not match. There is one by default policy is also there. There is a by default policy is also there. One is by default and one is user defined. So as soon as you can read this message, not match, this means attributes that the R1 is sending are not acceptable. So attributes are not acceptable, no offer accepted. Phase 1 security association policies are not, you will delete it. Now let's create the same policy. Encryption is AE. Some packet will be dropped, but working right. See, I told you that 6 packet will be exchanged, right? That is called main mode. You can see 1, 2, 3, 4, 5, 6. I told you in first packet, it is you will use UDP, right? User datagram protocol, right? Source port 500, destination port. In it, you will find somewhere all the policies. Yeah. See, I told you they will push the policies, right? I set my lifetime 1800. So he's sending lifetime authentication. PSK means pre-shared key. Group hashing key encryption algorithm. NAT is we will cover in CCNP. What is NAT? How it works. Now the first command for the phase 1. Show crypto isocamp SA. Source is this PC's IP. The destination is this. And this status should be always active. Make sure. If this is not active, this means your VPN is not active. It's not working. Show crypto IPsec. Here you can find it whether your packets are encrypting or decrypting. Encapsulation, encryption, decrypt. So if I will send a ping of 5 packet, 14 plus 5, 5, 19. Is it 19? Right, just right.